All right, welcome back, Calcsters. Today is Thursday, December 16th, and we're getting close to halfway through Chapter 4. Throwing that out there. All right, here we go. We're going to begin today 4.3. And 4.3, our focus is going to be on a super important idea, which we call the mean value theorem. Yes. Love it. Love it. Yes. I'm going to ask you about that in a second, okay? All right. We're going to learn the mean value theorem. Now, before we get into the mean value theorem, we're going to talk about another theorem that does exist. The implication of this theorem, and I've always thought this theorem just seems so silly to me to even conclude because I think it's obvious. I think you guys will once we kind of go over it. But the first theorem that we're going to learn is going to be called Rolle's theorem. And Michel Rolle, French mathematician, he was the guy that came up with this. I'm sorry. Yeah. Okay. Anyway, Rolle's theorem is the motivating factor in how we prove the mean value theorem. Really, really important. Rolle's theorem is the motivation behind it. So here we go. Let's give ourselves Rolle's theorem first. It's R-O-L-L-E. Rolle's theorem. Okay. We'll get a picture for this in just a second. First thing we have to do, let's give ourselves some stuff. We're going to say let f be a function, and I'm just going to say let f be defined on some closed interval from a to b. Okay, here we go. All of the theorems that we've ever seen, if you think back to geometry, they typically can be written as if and then, right? Our if statement, our hypothesis has three requirements that need to be met. So I'm going to straight up number them. If 1. Here we go. First thing, if you give me a function that's defined on from a to b and it's continuous, f is continuous. All right, that's our first step. Give me a defined function if you tell me it is continuous. And 2, f is differentiable, which have you guys, I don't think I've written this word for this class. Have you guys written down the word differentiable, Shane? I use diffable is what I use. Differentiable. What does it mean to be differentiable? There's such a better word for the slope of the tangent line. Derivative. I can take the derivative. If f is continuous on this interval and is differentiable on the open interval from a to b, which you may maybe you're wondering why does that have to be the open interval? Because at these endpoints it's just a point. You can't take the derivative there. Okay? And furthermore, f of a equals f of b. If these three things are true, then, and I'm going to sketch a picture and see if we can't kind of predict what we might want to happen here. All right. I'm going to sketch a little picture for it. I like working in quadrant 1 because it's nicer. I'll even make it more quadrant 1-y. And we're going to go from A to B. Now I can make, there's infinitely many choices of a continuously differentiable function between A and B. I'm going to go with one that has just a little bit of bend to it. Maybe it's kind of curvy. Is this function right here meeting those criteria? It's differentiable. It's continuous. And what's true about f of A and f of B? They're equal. Okay. This meets those criteria. Now, this isn't the only graph I can draw. I can draw it another way if I would like to. But here's what I kind of want to deal with. I'm going to make the claim that I know without a doubt the value of the derivative at a couple points. What do you think? Can you guys tell me with 100% certainty what the derivative is right here? Yeah. No, why do you want to say that? You're guessing. I want it with certainty. I can't do it there. I can't tell you the value of the derivative right there. Can't do it here, right? No idea. How about here? No, gosh. How about here? How about here? Think about it. It's 0.
Oh, I thought you were putting right next to the top.
The derivative is 0, right? This is max, right? This is an extrema. Okay. If this is true and f of a equals f of b, then, here we go, there exists. Anybody remember the shorthand? Backward capital E. If these three criteria are met, then there exists at least one C value. And we're just going to see at least one C value in the interval from A to B. Everybody remember that notation? If those criteria are met, then there exists at least one C in this interval such that f prime of C is equal to what, do you think? 0. This is Rolle's theorem. Now, don't add another one. I'm going to draw a different function, just in blue where the same thing's true. Here's a function from A to B that's continuous and differentiable, and f of a equals f of b. Can you tell me the derivative at any point on the blue graph? Everywhere, right? Okay, I can change the shape of this if I would like to. I'll do it here. What if it's just that guy, like a little part of a parabola? Is there a spot on that graph where the derivative is 0? Yeah, it's at the minimum. No matter what this graph is, it will always happen. Now, this idea on its own, not super crazy, but we get to use this as a motivating factor for a much more important theorem. Like, does this seem believable to you guys? Like, there's nothing really shocking about this, I don't think. Okay. What this does do, and Chanel, I'm just going to wait up for a second. I'll pause.
Do we have to draw those?
At least the first one. And on my notes, I have it. I just have 0 slope lines here, but I don't care if you have those or not, as long as you realize the derivative is 0 there. Okay. More important than Rolle's theorem, or an immediate consequence, rather, of Rolle's theorem, is the real meat of today's lesson. We're going to talk about the mean value theorem. Okay, you might see me write it one more time, maybe. I don't think I'm ever going to write it again. I lied. What do you want to call it? MVT. Now, Rihanna, right at the beginning, we're going to get a picture first before we draw our stuff. But the second that I said mean value theorem, you said a couple other words. Median and... Okay, median. Median and mean, those are both like statistics words, right? What's a mean? An average. Okay, you could call this the average value theorem, and it would work all the same. I'm going to sketch my picture over here. And I'm very specifically leaving space. Rolle's theorem, this is going to have some of the same requirements. I need, and we'll write all this down, but it still has to be continuous and differentiable. But Rolle's theorem says what must be true about f of a and f of b? Just f of a and f of b, it says they have to be equal. Okay. I'm going to go out a little bit further. I'm going to sketch a graph from A to B where f of a and f of b are not equal. Okay. So let's say it does something like this. They're definitely not equal there. All right. Digging way back. Oh, maybe not way back. If I asked you, on average, how fast is that changing? Do you remember ever doing that? Oh my gosh, it's just a slope. The average rate of change. Do you guys remember talking about the average rate of change? A rock? Okay, check this out. I'm going to draw a dashed line here between those 2 points. I'm going to dash it. You guys probably want this. Okay. This is a secant line. Okay. This thing represents the average rate of change. How would you find the slope? I'll even go back one more, and I'm going to name this function f. The blue one, f. How would you find the slope of this yellow line? And I'll even call that m sub secant. You're right, it will be y1 minus y2, but we have better language. What's the function? And the y value here is f of b. So let's do it as f of b minus f of a over what? B minus a. Okay. This is the average rate of change. I'm just going to put a rock there just to remind us. From a to b, that's the average rate of change of that function. Now, the mean value theorem goes further. I want you to just think about what's changed. On Rolle's theorem, what was the average rate of change between the endpoints? 0. At some point in the interval, there was a place where the derivative was equal to 0. I'm going to just eyeball it here. You think you could roughly sketch, even imagine in your head what the derivative might look like there? The tangent line right there. You think that's the slope of the tangent line? What'd you say, Jerwin? Doesn't it? I'm going to fix that point a little bit. Oh my goodness gracious. I'm still struggling. There we go. Perfect. Man, that's the slope of the tangent line. One more little step, just in case people didn't hear you, Jerwin. What'd you say? It's parallel. Now, do you agree that those lines look like they're going to be parallel? The slope of the tangent line is equal to the slope of the average rate of change, or the secant line. Could I change, like, you don't need to draw another one, but check it out if I do it like this. There's that function now. Here's my average rate of change, right there. Are there points on this graph where it looks like the derivative will have the same slope? I would say it's about there. I see another one like there-ish. That's I'm not holding shift. Weird. My finger's off a button apparently. That's about the same, right? Roughly. And that's about the same right there. Gosh. Let's figure out how to put this into words. Here is the mean value theorem. So we're going to do the same thing. Let f be defined on a to b. What were the requirements of Rolle's theorem? Okay, it has to be continuous. So we'll say if f is continuous on a to b. What was another requirement? Differentiable. And f is differentiable. I'll actually write it out just in case. On which interval? What's changed? Open interval from a to b. Now, Rolle's theorem only had one more requirement. It said f of a has to equal f of b. I don't require it here. I don't care. If these two things are true, then there exists a c in the open interval from a to b for which, and I'm going to let you guys catch up. f prime of c
Then why is it closer to
here,
of the differential?
because you can't take the derivative at this particular point. There exists a c, at least one, in this interval for which f prime of c equals what? Not 0, that'd be Rolle's theorem.
And the slope of the tangent?
The slope of the tangent is f prime, but it's going to be equal to the slope of the secant line, or that line, f of b minus f of a, all over b minus a, which is called the what? Average rate of change. I'll even put that right here again. A rock. Okay. Now, what this allows us to do, this oddly enough, has been used in a court case.
How?
Yep. We'll do a problem
That's
where
okay.
you might want to do it. Yeah, like actually used in a court case to show that somebody broke the law. Oddly
This
enough.
thing,
What's up?
this was used.
This was used. Okay.
I'm not gonna be able to
Now, there are 3 interpretations of this. The first one is exactly what we've written. The derivative is exactly equal to the average rate of change. There's the first one. Another way that you might word this is that the instantaneous rate of change is equal to the what rate of change? Not constant. Average. The instantaneous rate of change is equal to the average rate of change. It exists. It happens somewhere. Or that the tangent and the secant lines are what? Parallel. Those are the different interpretations of it. Now, I want to verify, or again, just really stress. All this tells me is that that point C exists. Does it tell me how to find C? This just tells me that I know that point is there. Finding it is going to be on us. So here we go. Example. Find C values or value. I'm going to put val with S in there. Find C values guaranteed by MVT. And what's MVT?
Most valuable T.
Mean value theorem. And it tells me that, hey, the slope of the derivative is going to be equal to the what?
MVT.
Nope. Average rate of change. Love it. All right. Here we go. Okay, on A, we're dealing with f of x is equal to the square root of x. And we're working on the closed interval from 1 to 4. Now, I really, really want to stress this home. I'm trying to find where the derivative is equal to the what? Average rate of change. That means I have to set derivative equal to the average rate of change. I have to find both of them. I don't care what we do first. Do you want to find the derivative or the average rate of change first? Derivative. Can you guys do this derivative in your head yet? F prime of x, I'm going to change that a little bit. It's 1 over 2 root x. 1/2 x to the negative 1/2, and it just moves downstairs. Cool, cool. Okay. Here's the derivative. We've got that knocked out. What else do I need? Let's find the average rate of change. How do we do that?
You take FB minus FA.
So that's f of 4 minus f of 1 over 4 minus 1, right? What's f of 4? 2. Because the square root of 4 is 2. Minus what's f of 1? 1 over 3. Oh, okay, it's 1/3. The average rate of change is 1/3, and I know the derivative. I need to think this out. Does this thing ever have any discontinuities on this interval, 1 to 4? No. Where is this thing discontinuous?
At the end.
Like that. Where doesn't this function work? Negative numbers. Every positive is fine. We're good. Okay. I then need to set this derivative equal to what? 1/3. Here we go. Let's do it. I want to know, when is it true that 1 over 2 root x is equal to 1/3? And I want your help with, I want you to do this tonight. Solve x.
Uh-oh.
Okay.
Yep.
I keep thinking you're Vincent. Putting the best of Johnny on the
Cool. I'm going to check your pages in the morning. Do this.